Hello. Today's first lesson will be about confidence intervals about a proportion. So here we have problem 1. 1 states a 2013 survey of 126 randomly selected United States citizens showed that 93 do not trust survey results. With a 90% level of confidence, construct a confidence interval about the population proportion of United States citizens who do not trust survey results. Before we get into any discussion as to how we approach confidence interval type of problems, we need to determine which is the correct sampling distribution that we use for these types of problems. We have two choices of sampling distributions. One is the standard normal distribution, and the other is the t distribution. Since this problem is a problem where we're looking for a proportion, and we know that because of keywords. It says construct a confidence interval about the population proportion of. The rest doesn't matter as far as determining which would be the correct sampling distribution. If we're doing a problem that deals with proportion, we will always use the standard normal distribution. Also, we can call it the z distribution. Problems that deal with means may or may not use the standard normal distribution. When we get to one of those, we'll discuss in detail whether we get to use the standard normal distribution or whether we have to use the other distribution that we'll be using called the t distribution. Now that we know for the problem at hand that we're using the standard normal distribution, let's talk about the parameters that we need to look for. The first thing is x. X represents the number of those who responded favorably to the survey question. In other words, this question asked, do you trust surveys? And out of the total of 126 people, as it says in the problem right here, out of the 126 people, it said 93 people do not trust survey results. So 93 actually responded favorably that they do not trust survey results. Or should I say, 93 of them explicitly stated that they do not trust survey results. N always represents a number of things or a number of people. And in this case, N represents the total number of people that were surveyed, which is 126 for this problem. We have this thing P with a little hat over it, and we pronounce that P hat. That represents the proportion of those in the survey that responded favorably to the way the question was asked. And P hat always equals the number of people who responded favorably divided by the total number of people that were asked the question in the survey. We have Q hat, and it's pronounced Q hat, and it represents the proportion of those in the survey that did not respond favorably to the way the question was asked. In order to get that number, we just subtract P hat from 1, or 1 minus P hat equals Q hat. Something that you should always remember in probability and statistics, that a Q is always equal to 1 minus P. The next thing that we're looking for is the Greek letter alpha, lowercase alpha. And that represents what we call the level of significance, or the area of error. Alpha is always the complement of the level of confidence to 100%. In other words, for this problem, since the level of confidence is 90% or 0.90, the level of significance is 100% minus 90% or 10%. But we typically write it as a decimal, so we would write it as alpha equals 1 minus my level of confidence, or in this case 1 minus 0.90, which is equal to 0.10. It's also important to note that some of these problems won't even state a level of confidence or a level of significance. We have a default value for that. The default value for a level of confidence is always 95%. In other words, if there's no level of confidence or level of significance shown in a problem, we just use 95% for my level of confidence and 0.05 for my level of significance. So for this problem, since my alpha is 0.10, we're really concerned with half of that error in each tail. In other words, 0.05 would go to each tail. If alpha is 0.10, then alpha over 2 is 0.05. Next, we have this thing we call z sub alpha over 2. And that represents the z value that corresponds to the error area in the right tail. It must be a positive value. At least it needs to be a positive value for confidence intervals. In the future, we're going to talk about something called hypothesis testing. And in hypothesis testing problems, the z sub alpha over 2 could be positive or negative. But for confidence intervals, we always use the positive z value. So we're using the one that corresponds to the right tail. The only way to really find this is to look it up on a table or to use our spreadsheets, which is essentially looking it up in a table. And when we do that, for this problem, remember alpha over 2 is 0.05. And as you can see on the standard normal curve, we split that up into two tails. We have 0.05 on the right side and 0.05 on the left side. What we're looking for is this z value right down here. In other words, it's going to be between 1.5 and 2. So I'm not sure what it is yet. The only way we can do that, as I said, is to look it up on a spreadsheet. And when we go to spreadsheet mode, you'll see all of that and how I got that. So if I were to say I want you to do this right now, and we need to find the z value that corresponds to 0.05 in the right tail, we would type in on the spreadsheet equals norm.s.inv of 0.05, or whatever the cell reference is where the 0.05 is. And if we saw that, our result would be 1.645. So here's 1.5, 1.6, and 1.645. Looks like that's about right here. We would have a z of alpha over 2 of 1.645. Actually, when we put it into the function on the spreadsheet, we get the negative 1.645, but we actually need the positive value. So how do we always get a positive value out of that? We simply take the absolute value of our result. That will always give us the positive value. After we get the z sub alpha over 2, we have this somewhat complicated formula to calculate this thing called E. What we do with E, I'll explain that in a little bit, but we're almost done getting all of our parameters to get to our final answer. For this problem, we now have n is 126, that's given to you in the problem. X is 93, also given to us in the problem. We have p hat, which is 93 over 126, or approximately equal to 0.7381. Q hat is equal to 1 minus p hat, and in this case, it's approximately equal to 0.2619. We take all of those things that we got, including the z sub alpha over 2 number, and we put it into this formula for E, and we get that result. After we get that result, the rest of this is very easy. In fact, the whole thing is easy because we'll end up doing this whole thing on a spreadsheet. E is equal to 1.645 times the square root of, this is p hat, 0.7381, times q hat, 0.2619, all over n. When I do the arithmetic, and remember that's all done on the spreadsheet, it's approximately equal to 0.0644. We're done with the hard part. That E gives me my error. And what I do with that error is I subtract it from p hat, I get a result, and I add it to p hat, and I get another result. In other words, for this problem, on the left side, we would have 0.7381 minus 0.0644 is less than p, or the population proportion, which is less than 0.7381 plus 0.0644. When we do the simple arithmetic here and here, we get 0.6737 is less than p, which is less than 0.8025. What this means is that the population proportion is between 0.6737 and 0.8025. One of the biggest problems that students have in probability and statistics is interpreting what a result actually means. So let's backtrack a little bit. First, we took a survey. We had about 126 people in that survey, out of which 93 stated that they find surveys to be untrustworthy. We take that proportion, 93 divided by 126, and we ended up with a number, 0.7381. That number is what we call a point estimate of the population proportion, meaning that it's a single number, and that single number we can use as an estimate for the population proportion. We don't know how accurate that number is. Depending upon how big my sample is, it probably, can be more or less likely. When we find a confidence interval, we're picking a level of confidence, and we end up with a range of values. And that range of numbers, we can be confident that if I were to go out and survey the entire population under consideration, I can be, in this case, 90% confident that true population proportion of those who find surveys to be untrustworthy would be somewhere between 0.6737 and 0.8025. So how would we state that answer? How we would state it is like this. We can be 90% confident that the population proportion of those that find surveys to be untrustworthy is between 0.6737 and 0.8025. Let's go to spreadsheet mode and do this problem on a spreadsheet, because that will help us with the next few problems. Here I am in spreadsheet mode, and let's type in the stuff that we already know. The stuff that was basically just given to us in the problem. They gave us an X. Remember, that's the number of people who responded a certain way. So that was 93. Total number of people was 126. How did we get p hat from that? Well, p hat is going to equal 93 divided by 126. And that's where I got the 0.7381 number from. I rounded at the 10,000th place. How do I get Q hat now that I have P hat? Remember, Q is always 1 minus P. So I would type in equals 1 minus my P hat value. And that's where I got the 0.2619 number from. We let the spreadsheet do as much work as we can, and that's why I don't just type in the literal for Q hat. I type in a formula so that if these ever change in another problem, then that'll update my P hat and Q hat. And we can always use this spreadsheet when I'm talking about confidence intervals about a proportion. Next, we're talking about the level of confidence. If you remember from the problem, that was explicitly stated as a 90% level of confidence. On the spreadsheet, I'm going to type that in as 0.90, and you'll see it just automatically defaults to 0.9 because it's the same as 0.90. Alpha, remember, is the complement of the level of confidence. And that, just like a Q, is always a 1 minus a P. Alpha is always 1 minus my level of confidence expressed as a decimal. So we're going to type in equals 1 minus 0.9. Alpha over 2 is simply what it looks like. We divide alpha into 2. I would say equals. I click on the cell that contains my alpha value, and then I would do divided by 2 and enter. Z sub alpha over 2. Well, for that, remember, we use a special function built into spreadsheets. And that function is the norm.s.inv function. And you'll see what that looks like. Equals norm.s.inv, and then open parenthesis, and it's asking for the probability, which is what I call area. Remember, those are synonymous. Click on that, and then I close my parenthesis, and I press enter. Now that gives me a negative value, which I approximated on the wording as 1.645 But if you see 448, this 4 would round up to 5. But again, this number is negative, so I am going to make it positive. In other words, I really just want the positive result, so I take the absolute value. We haven't talked about the absolute value function yet. It's a canned function. It's built into Excel, and we just use ABS for absolute value. So that equals the ABS, open parenthesis, click on the cell with the z sub alpha over 2 that's negative, close my parenthesis and press enter, and you'll see it just gives me the positive result. Now to find E. The formula is E equals z sub alpha over 2 times the big square root of p hat times q hat over n. Let's go back to spreadsheet and try to type all that in. E equals, first thing we want to do is the z sub alpha over 2 positive. So that will equal, I'll click on the cell reference that contains that, times, now we haven't discussed the square root function yet. Another canned function, it's built into Excel, and it's a pretty simple one. It's just SQRT. We're going to open parentheses. We can just type it in directly. The order of operations in this case is just directly, it just works out. So we don't have to worry too much about putting extra parentheses in or whatever. So this will equal the square root of, let's see, p hat from the formula times q hat divided by the number of values that we have. I will close my parenthesis and press enter. And as you can see, it's that number that I had on the spreadsheet, 0.0644. Now for the easy part. On the left side, what we do is we take p hat and we just subtract this e value. So equals the cell that contains p hat minus the cell that contains e, and that's on the left side. And as you can see, that's 0.6737. It shows here 0.67366 something, but again, at the 10,000th place, that should be far enough to go. We would round, and in this case, the 6 goes up to a 7. And on this side, we would say equals whatever p hat is plus e, and we get the 0.8025 number. So in other words, this is my confidence interval right here. This means that if I were to go out and get the entire population proportion of those who would find surveys to be untrustworthy at the 90% level of confidence, I can be sure that it will be between 0.6737 and 0.8025. Let's take a look at problem number 2. Now that we have the basics, we're going to cover this one a lot faster. A survey of 1,103 randomly selected Americans showed that 281 thought the sun goes around the earth. With a 97% level of confidence, construct a confidence interval about the population proportion of Americans who think that the sun goes around the Earth. Being that this problem is a proportion problem, just like the last one, the correct sampling distribution is the standard normal, or the Z distribution. Our level of confidence is 97%, or 0.97, which implies that our alpha, or error area, is 0.03. Alpha over 2 is 0.015. When we look that up on the spreadsheet, we will get a Z sub alpha over 2 of 2.17. On the Gaussian curve with a mean of 0 and a standard deviation of 1, this is what it looks like. This area right here represents 1.5%, or 0.015, and this area right here is 0.015 on the right side. Our parameters are as follows. N, or the total number of people in the survey, is 1,103. X, or the number of people that responded in a particular way, is equal to 281, which means that p hat is 281 over 1,103, approximately 0.2548. Q is always 1 minus p, so Q hat is 1 minus p hat, and that's approximately equal to 0.7452. Here is the formula for E with the parameters plugged in. This is what my confidence interval works out to be after I subtract my 0.0285, or my E, from p hat, which is shown over here, and when I add 0.0285 to my p hat, which is shown over here. When I do the simple arithmetic on that, I get a confidence interval of 0.2263 is less than the population proportion, which is less than 0.2832. In other words, because we use the 97% level of confidence, I can be 97% confident that if I surveyed the entire population under consideration, that somewhere between 0.2263, or 22.63%, and 28.32% of Americans in this case would think that the sun goes around the Earth. Let's pop this on a spreadsheet. We'll go right to spreadsheet mode. You'll see how fast this goes. Here we are in spreadsheet mode. My X from problem 2 was 281. That's the number of people that responded in a particular way. My N, or the total number of people in the survey, was 1103. Now, I just realized that I made a mistake when I originally set up the spreadsheet, so let's correct it now. It's kind of a simple mistake. I typed in a literal, meaning I typed in equals 93 over 126, which was from the previous problem. But that's an easy fix. All I have to do is change that to equals, and then I'm going to click on the actual cell that contains my X value, which is what I didn't do last time, divided by the cell that contains my N value. Make sure you make that correction, or it's always going to show up with the same p hat value. And there we go. And now these numbers match up to what I had on the actual problem and then the description of the solution to the problem. My level of confidence is 0.97. Alpha becomes 0.03. Alpha over 2 is half of 0.03, which is 0.015. My z sub alpha over 2, or the z value for the left tail, is negative 2.17. And the z value for the right tail is just the positive of that, so it's positive 2.17. When I put that in the formula for E, I end up with, again, the number that I showed you on the actual description page of the problem. I end up with 0.02847, or I might have put 0.0285. And when I subtract that number from my p hat value, which is this number on the left, that's what I get. And on the right side, I get the 0.2832 number from adding e to p hat. If I were to interpret this result, it would mean that we can be 97% confident that the population proportion of those that believe the sun circles around the earth is somewhere between 0.2262 and 0.2832. Or you could say it as a percent. We can be 97% confident that the percent of those that think that the sun circles the earth is somewhere between 22.63% and 28.32%. So you see, once we have these spreadsheets set up, this goes very quickly. And now we're done with problem number 2. Let's take a look at problem 3. Problem 3 is different from the others because we're not actually looking for a confidence interval. What we're looking for instead is a minimum sample size necessary. Now, what that means is it should be somewhat intuitive that the more people you survey or the more samples you take, the larger the number of times you run a trial of an experiment, etc., you'll get closer and closer to what the actual population parameter is. For this type of problem, what we're asking is, what would be the minimum sample size to meet specific criteria? It's actually not that difficult to do. It's not as detailed as finding a confidence interval, but it's a very similar process. Basically, what we end up doing is reverse engineering the formula to find E, and we work that backwards and we solve it for N. Let's take a look at this problem first. About 3 months prior to an election, a candidate's constituents were polled, and 42.1% stated they would be in favor of a Medicare for all type of medical plan in the United States. A new survey will need to be taken about a week before the election to see if this number has changed. At the 92% level of confidence, determine the minimum sample size needed to be within 2.5% of the population proportion of those that wish to have a Medicare for all type of plan. This is a problem of proportion. So the correct sampling distribution, just like all the others, is the Z distribution, or the standard normal distribution. And since we're looking for N, but I only gave you the formula for E, we reverse engineer it. So if E equals E sub alpha over 2 times the square root of P hat Q hat over N, and I'm not going to take you through all the algebra, but basically that means N equals P hat times Q hat times z sub alpha over 2 over e squared. Now that we know the sampling distribution and we know the formula, the next question that you should ask yourself is, was a previous poll done with the same question? If the answer is yes, we use the previous poll's result for p hat. If this is a new survey, or if we wish to start a new one on the same issue, we use p hat equals 0.5. In other words, the default p hat when we're looking for a minimum sample size is 0.5, meaning 50%. But for this problem, it states explicitly that we had a previous poll, and that previous poll showed a result of 42.1% being in favor of Medicare for all. So we use that for p hat, except we write it as a decimal, so p hat equals 0.421. The parameters, we have n equals, that's what we're looking for, p hat equals 0.421. Q hat is always 1 minus p hat, and that ends up being 0.579. E, the key word you should be looking for when we want to find E. In these types of problems, E needs to be given to you because that's just one of the criteria upon which we calculate the minimum sample size. So let's go back to the problem and see where I got that 0.025 from, and also what the key word is. Here's the original problem. It says needed to be within 2.5% of the proportion of those, etc., etc. The key word here is within. There are other keywords, but usually the word we use is within. Any other word would be a synonym. So that's the key word to get E. My level of confidence, that's given in the problem. But remember, if it's not, and if a level of significance is not given either, then we make the assumption that the level of confidence is 0.95 or 95%, and that my level of significance is 0.05. But the level of confidence explicitly stated as 92%, which means that alpha is equal to 0.08. Alpha over 2 is 0.04. When we look up z sub alpha over 2, and again, we're going to put this on a spreadsheet, we get 1.7507. And we get that from the norm that asks that inverse function on the spreadsheet. When I do the whole calculation by the formula, here I have n equals, this is p hat, this is q hat, this is z sub alpha over 2, this down here is e, and I square that result and multiply it by these things, and I get 1195.355805. However, n always represents a number of things. We cannot break that up into portions of things. In this case, we're talking about human beings, and obviously we can't have a portion of a human being. So, no matter what the number is to the right of the decimal place, we will always round the number up. In other words, if this were 1195.0067, we would still round it up because this is a necessary condition for us to meet. And 1195, if we round it down, that wouldn't be enough. 1196 is a slight overkill, but since we can't break it up into a portion, then we would round up. Let's see what this looks like on a spreadsheet. Here we are in spreadsheet mode, and I have it set up already. E for this problem is equal to 0.025. P hat is equal to 0.421. Q hat will let the spreadsheet do that. That will be equals 1 minus whatever we got for P hat. My level of confidence, 0.92. My alpha value is 1 minus my level of confidence as a decimal. So that's going to equal 1 minus my level of confidence. Alpha over 2, obvious. Just divide alpha by 2. And I'm going to nest two functions together. I just want to get the positive result, as I said. So I'm going to take the absolute value of the norm.s.inv. So if you have to pause this, then do so that you get the function correct, equals the absolute value of norm.s.inv. I open another parenthesis. Excel is pretty good. If you see it has colors, when I close my first parenthesis, it's going to be for the norm.s.inv function, and you'll see that one will be red. And then when I close the second one, it will be a black one just like that. So norm.s.inv of my alpha over 2 value. I close my parenthesis and watch, it'll be red to show I'm closing the norm.s.inv function. And now I'm going to close the absolute value function. And you'll see it's black, just like the one that opened the absolute value function. So make sure you type that in carefully and make sure it looks something like that. And that way we just don't have to do the thing twice, getting the norm.s.inv and then getting the positive result. And we get 1.75068, etc. I rounded this on the problem page to 1.7507. Now we have to put this into the formula. It's not so complicated. Just pay attention to how I'm doing this. It will be equal to P hat times Q hat times, and now I'm going to open a parenthesis, and we take our z sub alpha over 2, and we divide that by e. I'm going to close my parenthesis, and we haven't discussed exponentation. To create an exponent to the power of, we call it a caret. It's shift 6. And you see how that turns out. It's raised to the power of, and in this case, 2, and press enter. And you'll see we have the same number that we had on the problem page. Over here, we have a really cool function. Excel spreadsheets have round, but they also have one called round down, and they have one called round up. And then you tell it how many decimal places you want it to go. And when they ask that question in the function, they mean how many decimal places to the right. So I'll show you that function. It equals round, and you'll see we have round down, round up, and I have no idea what M round is, but there's something there for that. So I'm going to click on round up. And no, it's not the insecticide. Some people will get that. The first thing, it's asking for a number. And the number comes from right over here. It says n is greater than or equal to, comma, and it says the number of digits. It means the number of digits to the right. So basically we just put 0. In other words, we don't want anything to the right of the decimal. Now I'm going to close my parenthesis and press enter, and you'll see it gives me the 1196 number. And well, that's about it. I mean, that is the minimum sample size necessary to be 92% confident and to be within 2.5% of the population proportion of those people who would want Medicare for all. Let's go on to problem 4. Problem 4. A survey will be conducted in Canada to determine the overall satisfaction with Canadian healthcare. Determine the minimum sample size necessary to be within 3% of the population proportion of those that are satisfied with their healthcare in Canada. Again, this is a proportion problem, so the correct sampling distribution is the standard normal or the Z distribution. There's no level of confidence that's specifically asked in this problem, so we default to the 95% level of confidence. Also, there's no previous study mentioned. There might be a previous study, but there's not one mentioned for this, so we consider this to be a brand new study. The default is we set p hat equal to 0.5. Let's take a look at our parameters. N, that's what we're looking for. P hat is 0.5. Q hat, well, that's 1 minus p hat. So Q hat is 1 minus 0.5, which is also 0.5. E, given to us in the problem, that whole statement within 3%. My level of confidence not given in the problem, we use the default of 0.95 or 95%. Alpha is equal to 0.05. Alpha over 2 is 0.025, and z sub alpha over 2, using the norm.s.in function, is equal to about 1.96. We pop that in the formula, and is equal to p hat times q hat times z sub alpha over 2 over e squared. And when I do all the math, I get 1067.1, which is approximately equal to 1068. So that would be my minimum sample size. Let's see how easy this is to do on a spreadsheet. E, well, we stated that was 0.03. P hat, that was not given to us in the problem, so that will be 0.5. And then Q hat populates with 0.5 as well. Level of confidence, not given in the problem. We default to a 95% level of confidence, or 0.95. Alpha populates as 0.05. Alpha over 2 is 0.025. That gives me a z sub alpha over 2 of 1.95996, etc. No matter where I round this, it's still going to be 1.96, and that's why I put 1.96 on the problem page. When I crunch it in this formula, And again, here is the formula if you need to see it. When I put all that in the formula, I get 1067.071895. But because there's already something to the right of that decimal, we have to round up because we cannot have a portion of a whole for n. And we would get 1068. So 1068 is the minimum sample size necessary in order to be within 3% of the population proportion of those in Canada who are satisfied with their healthcare system. This will conclude this video. I'm going to pick it up from here with other types of problems. So see you in the next video.